Good afternoon. Sorry for the delays. I have a computer that doesn't like dual displays, so we had to quickly change some things around. My name is Joergensen. I'm a reference librarian at Rutgers University. I also deal with databases a lot in library school, took a lot of database courses, and had to take a lot of classes on things like data modeling. And that's basically what I'm going to be talking about today. What I'd like to do is, instead of doing just a straight presentation and talking at you the whole time, I'm going to be throwing up some examples, some things I'd like to talk about at different points. I might even ask questions. If there's no objections to it, I'd like to run it kind of as a class. What I intended this for is people who have been working with databases, who would like to work with databases, but would like some better background on things like how you should structure tables, what's called data modeling, in order to ensure that you don't lose data. When I was thinking about how to do this, I thought it would be simple. Just talk about things like normalization, how to structure tables. And when I actually started organizing this presentation, I started panicking because trying to gauge the user level of people who are likely to be in this room was just a nightmare. So what I'm doing here is I'm doing it at what I think is a fairly basic level. If anybody wants me to go faster, please just interrupt me. So I'll just start and we'll go from here. So tools for ensuring data integrity. Why is normalization important? Normalization is a basic concept on how to structure tables, how to split out data that's liable to get lost, and how to link tables together. Basically, there's 3-4 kinds of things that can possibly happen. Number one, very often happens is you get things like orphan tables, or orphan data. You have two tables that are linked together that are not linked together well. And the data in one table is linked to another. You delete one record, and then you have records in another table that are hanging. How can that happen? Like if you have a database of, say, employees of your school, and then you have another table that's got dependents of the employees of that school. Well, when you get rid of the employee, like an employee leaves, you want to delete their record from the main table. If they're not linked correctly, all those children and the dependents are going to stay. It's an orphan record. It's linked to nothing. That kind of thing happens a lot. Data loss. Say, tracking law firms that alumni work at. If you just have a flat file of all your alumni and then the name and address of the firm they're working at, well, if you've only got one of your alumni working at a law firm, when you delete that one alumni for one reason or another, all your record of that law firm is going to go away, which may or may not be a bad thing. It's something that you don't necessarily want to do, though. You want the record of the law firm to stick, even though you may temporarily not have anybody who actually works there, things like that. Duplication. Not necessarily a bad problem, but it's something that you're going to get most complaints about. Tables that are not linked well together and a system that's not done well, you have to do a lot of retyping all the time, like addresses, phone numbers, things like that. The goal you want to reach with good normalization and a good data model is that when you type one thing into the database, you never have to type it again. Along with duplication, data loss, and orphan records is, of course, when you try to get data out of the system, it's not going to happen correctly. When you've got a lot of duplication, we'll see, violation of first normal form. When you type everything over and over again, typographical errors are going to happen. They're going to creep into a system. And when you start getting to a database of a decent size, even just a couple of hundred records, things start to change. Typists start to make mistakes, people make abbreviations of different kinds, and then your control over the system falls apart. And there are ways to prevent all that from happening. So we're going to ensure data integrity by preventing orphan records, preventing loss of important data, and reducing or eliminating duplication of data, and improving query accuracy. An outline. These are just some of the key terms we're going to be talking about. The idea of a key field, of a foreign key, a composite key, normalization, relationship cardinalities, that's the numerical relationship of one table to another, and parent-child tables. Okay, first, key field. It's going to be an attribute that uniquely identifies a record in a table. It cannot have a duplicate. And most systems, you don't really have to worry about that. When you designate a key field in a table, by default, most systems won't let you duplicate it. It also won't let you have a null field. It can either be atomic or composite. Now, has everybody here used a database system like Access or anything at all? Anybody that hasn't? Okay, you'll find when Access is a good example because it tries to prevent some things. When you try and create a table and you try and save it, it'll tell you if you haven't put in a key, don't you want to designate one now? And it tries to put in an auto number field for you, which you should generally try to avoid, but it tries to do it for you. A key field is you take one of the fields that you've got, something that's going to not be duplicated at all in a record. If you're doing people, social security number is a wonderful one because every single person is going to have an individual social security number. Names are usually very bad unless you've got a very small table because sooner or later they're going to repeat. Again, can't be null, otherwise there's going to be no key to it. By atomic, I mean just a single field, like social security number in a table. You can also, however, have a composite key. For example, like when you're talking about an employees and then their dependents. Well, the key for the field of dependents, you probably want it to be linked, so you're going to want the social security number of the employee, but that's not going to uniquely identify each dependent, so you can have the name of the dependent. So the combination of the two is going to give you a unique identifier. That would be an example of a composite key. We'll talk a little bit more about that a little later. So an example of a single key table. You have employees, this is the table, and these are the fields in the table. You probably want more fields, but that's just an example. Social security number would be a good key for it. Composite key, so employees' dependents, you've got an employee, social security number, and the name of the dependent. If you've got two people named Jones who work in your place, and they've each got a daughter named Julie, the name's not going to work for you, but the combination of the social security number and the name is going to do what you need to do. Is this clear to everybody? Is this way too basic that I should be moving a lot faster or go on to something more interesting? Beg your pardon? Okay, well, keep moving. Okay, foreign keys of a table. These are the things that make relational databases truly relational. The way you go about linking tables so that they stay together is that you take information, a field that's in another table, and you put it in your table. The advantages to this, it prevents deletion, and then you designate it as a foreign key by linking them together. Now, depending on the database system you're working with, that's going to happen different ways. Again, in Microsoft Access, you go to the relationships box there and you actually draw a line between the two tables, and it'll set up a relationship for you. But it'll prevent deletion of records that have related data in other tables. So orphan data is eliminated. It prevents input of data that does not exist in the foreign keys main table. And it facilitates cascading updates and deletes between related tables. So what's going on here with foreign keys? If you've got something actually designated as a foreign key, you'll notice, and unfortunately I had some examples that I could show you from Access, but that's not available right now. If you bring up a record that, say, you have employees and the department that the employees work in, and you've got these linked together so that in your employee records you have a field that says department, and you've got the department number that they work in. And then for some reason or other you want to get rid of the marketing department. It's being shut down, you don't need it right now. Somebody tries to come along and update the database by eliminating the marketing department from the table of departments. If you've got a well-constructed database that's got that as a foreign key in the employees table, the database will stop that person and say, no, you can't delete this record because it has related records in another table. You first have to go through employees and reassign them from their departments or get them out of the employees table. Then you can get rid of that marketing record from the department's table. It puts control on there. It keeps you from getting those orphaned records. It's also seen as a big pain in the neck by the people who actually use the databases because they just want to get rid of that department. But it's something that you don't want to allow people to do. One of the things you can do, which can be dangerous, but under certain circumstances you might want to do it, you can allow something like a cascading update or a cascading delete. And when you set up a relationship, you can designate it as allowing to do that. Access makes that very easy because they have it right there in the dialog box when you draw that line between two tables. It'll ask you if it allows cascading updates and deletes. If you allow a cascading delete and you try and get rid of that marketing department, it'll say, do you want to do a cascading delete? And then it'll get rid of the employees. Which, if you're really into re-engineering your company, I mean, that's a good thing maybe, but something that you want to think about before you actually just automatically click allow cascading updates and deletes. So an example of a foreign key, just so you see how it is. Employees in the department. So one-to-many relationship, many employees for each department. Every employee can only work for one department. Every department has many employees. And employees have department ID number as just one of the fields in that table, but the key of the department table is the department's ID number. And you have them linked together, and department ID is declared as a foreign key within the employees table. So anytime you try and do something with department, it's going to look and see if there are related records in employees, and it may prevent you from doing the wrong thing. Normalization, which is really the important thing. So now that we understand what a key is and a foreign key is, we can talk about normalization. There are rules for deciding what to keep in a table and what to split off into a separate table. When will keeping a field in a table affect referential integrity? Well, the references between records in different tables, will it keep them straight? Okay, the core concept is something called functional dependence. I was trying to think of a good pithy definition, and it's very difficult to get my mind around it. Once you understand what a functional dependency is, you look at it and you say, yes, that's a very descriptive phrase all on its own. Functional dependence, how it works, and it's how it depends. If you're not familiar with the term, it doesn't make any sense at all. But I think as we go through normalization, it'll become clear what a functional dependence is. So I'm not going to worry about it right now, but I will in just a minute. First normal form. All values in a record must be atomic. This is something that gets violated all the time. And I don't know, there's been several faculty members that I've helped at different times redo databases to get rid of this. An example of somebody violating first normal form would be something like, you've got a database of articles that you're keeping track of. So article. So the title, etc., etc. And then you want to describe it with maybe some keywords. One of the ways that's often used to take care of that is just to have keyword as a field. What are you going to put in this field here? Whatever. You may put, torts, New Jersey, whatever. And people put in several words in here. A table that's got this kind of structure is not in first normal form. What's going to happen when you try to search for every article that involves torts? Well, number one, it's going to be a pain in the neck to structure the query because you're going to have to use all kinds of wildcard characters all over the place just to find the word torts in this field. Because, of course, the very next record is going to be somebody doing New York torts. So in order to get both of these records to come up properly, you're going to have a whole bunch of asterisks or whatever here on this side and on that side. It's a pain in the neck. Also, as we talked about before, another thing that's going to be a big problem is, well, torts is a very short word. People may type it the same way every single time. Is somebody going to make a typo? Well, when you've got a couple of hundred records, probably. And once you make a typo, you're not going to get that article. And if you've got a longer descriptor term, you're going to get that many more mistakes. So something like this, not in first normal form, your query recall is going to suffer, and it'll keep suffering the more records you put in it. So what do? You split it out and make it into a separate table. This will become its own table of keywords. And you would link them together with foreign keys. Second normal form. Tables must be in first normal form, and all of the attributes, the fields in the table, must be functionally dependent on the key. Okay, what it means is that if you look at the information in the record, does that record really depend on the existence of the key field in order to be there? For example, if you've got a table of people, say employees again, it all depends on social security number. Well, let's look. What about their name? Does the name of the person really rely on social security number? Well, in the sense of functional dependency, yes. You've declared social security number as the key, the identifier of that person that you wish to describe. And their name doesn't relate to anything else but the person. So it's functionally dependent, and it belongs there. What about the department they work in? Well, the department they might work in, it's functionally dependent on a whole bunch of things. Key is that it's not functionally dependent on that particular person. So, for example, if there was a table of people, well, actually, let's stick with this as an example. You have articles, the title of the article, keywords we've already taken care of and gotten out of there. What about that's spelled really horribly, but that's journal. What about the journal that the article's in? Well, you're concerned about articles, so that's the main thing of the table. The key of the table is the article. You probably got an article number as a key field. Is the journal that it's in dependent on that article number? No. If anything, probably just the opposite. So, would you want journal in there? No, you wouldn't. You'd split that out into another table. Again, what's going to happen if you leave it that way? Number one, you're going to have to type the same thing over and over again. Every time you've got an article that's in the same journal, you have to type it again. You're going to make typos. Somebody may put in, maybe the Blue Book abbreviation. Somebody else is going to put in the full name of the journal. Queries and recall is going to go down to 0. Beg your pardon?
It jumped
Oh.
slide after you walked over the list of days.
The center one.
The center one?
And the center. And then again.
Okay, thank you.
You're welcome.
Okay, back on track. Third normal forms, tables must be in second normal form, and attributes are dependent on nothing but the key. I'll get to an example of that in a second. First normal form, again, any field which you would want more than one value per record should be split off into a separate table. Again, they're almost impossible to search, invite typographical errors, and they are prone to destroying valuable data when the records are deleted. And again, we've already kind of discussed this already. It's second normal form violations are a prime source of useless data loss, inaccurate recall and queries. You got to look for the functional dependence in each field that I described before. The question to ask is, if I delete this record, do I want this part of the data to disappear? If no, then you want to split it off. And again, thinking about the concept of functional dependence and what it is, probably the best definition I can think of is ask yourself this question. And if the answer is no, then it's not functionally dependent and you split it out. If the answer to this is yes, then it is, at least for the purposes of second normal form, it is functionally dependent and you want to keep it in. Okay, third normal form. When there's an attribute that depends on the key, but it also depends on something else that is not the key. Okay, what could that be? An example that, this is not a great example, but it's a good illustrative example. If you've got people's, again, if you're keeping track of people, you've got social security number, you've got name, you've got their street address, you've got their city, state, and for purposes of this example, for example, if you want the full name of their state that they live in, plus you also want the mailing code, the 2-letter mailing code. Now, it's possible that you could want this in a database. And for the purposes, again, of an example, let's say we want to do this. This is a violation of third normal form. Why? Because, again, you have to constantly correlate the two things together. The address of the person is something that appertains to that person and nobody else. So having the city, state, and zip, the city and state code is a good thing to have there, but do you want it this way? Well, since the abbreviation depends entirely upon the state that they live in, the full name of the state, this is something that itself is a violation of third normal form. So the fact that it's CA appertains to the address, which appertains to the person, so it's good to have it there. But since it depends on something else as well, that makes it a violation of third normal form. So you'd want to split these things out into their own table. So you'd take the offending attribute and the element that it depends on, both into another table. And then you would link it back in to your initial table. Another thing, this is much simpler, that we just have to keep track of, is cardinality, determining numerical relationships. You have one-to-one, one-to-many, many-to-many. SQL, the compliant database system, will keep your data straight by enforcing the relationships that you define. So one-to-one, you actually don't find very often. And when you do, what you probably want to ask yourself if you have a one-to-one relationship is whether you should fold the one table back into the other. A time when you would find something like this is, again, this is probably a bad example because what's the problem with this table? Actually, good time, ask your question. There's a big problem with this table, or relationship. Yeah?
The title was repeated.
Beg your pardon?
The title was repeated. Bottom head and title, same thing.
Yeah, maybe. Yeah, if this is manager, sure. Another problem with this, actually, I have to apologize. This one's all right, because what I'm doing is it's the department head social security number. So if the department only has one head, then it's a one-to-one relationship between the employee and the department head employees. If this was just plain social security number, this would be enforcing a one-to-one relationship between employees and departments, and you could only have one employee per department, which, you know, unless you've got a very special kind of place, is just not working right. Again, it's more rare than one might hope. Rule of thumb, if you have a one-to-one relationship, make sure the data really needs to be in separate tables. And again, see second normal form rules to see whether it's functionally dependent. In this case, if you have a department head and you want to list that in your department table, this is the way to do it. You've only got one department head per department. An employee can, at least according to the rules described here, an employee can only be the head of a single department, which again may or may not be true in a given organization, but in here, that's what would be enforced. So in this case, you wouldn't want to roll the employee into the department or vice versa, but you'd want the one-to-one relationship. One-to-many, the thing to keep in mind is that the linked fields on the one side must be the key. So if you've got a bunch of employees that can be in a department, but every employee can only work for one department, the foreign key has got to be over on the many side. That's what makes the whole relationship work. And again, when you make the link between, that's what would be identified in the employees table as a foreign key. Many-to-many relationships can drive a lot of people crazy when you first start working with things like databases. They're fairly easy to do, though. You think of the two things that you want to keep track of. Like in this example, you've got a list of professors, a table of professors, and you've got a table of the degrees they can possibly have. And then you want to link them together. Well, a professor is probably going to have more than one degree. And then for each degree you've got listed, you've almost certainly got more than one professor having each one of them. So it's a many-to-many relationship. What you actually want to do is take the fact that there's a relationship and make that into a table. So, and it's going to be a simple table with a composite key. And the composite key is actually the key of professors and the key of degrees. And they come together. This works because you'll always have a unique combination of these two. You know, if somebody's got a BA, an MA, and a PhD, for each professor ID, you're only going to have BA, MA, PhD for that person. And each one of those combinations of the two is going to be unique in itself, but it's never going to repeat. Does that make sense? Does anybody have any questions about that or how it works? Okay. Another thing that should be dealt with that I'd just like to talk about is the concept of a parent-child table. Okay, where the contents of one table is wholly dependent on another table. But again, where the inclusion of the data in the main table would violate first normal form or third normal form, and/or third normal form. Big example of that is, again, what I was, the original example I talked about. You've got employees and their dependents. Well, you wouldn't have the dependents at all unless you had the employee to begin with. So if you got rid of the employee from the employees table, would you want to keep the dependents there? Probably not. It's a case where you'd want to split them out because you would have a repeating field if they had more than one dependent. So it would violate first normal form to have the dependents right there in the same table with the employees. At the same time, so you want to split them out, but at the same time, they still depend on the existence of the employee. So that's the nature of a parent-child table. It's the kind of situation where you'd want a cascading delete. to be in place. Again, the key of the child table, since it has that dependent relationship, the key is going to be the key of the main table and then of another field. So the example is going to look something like this. You've got your employees with their social security number and their name. So I'll make that one table. So you've got your table of dependents. And the name of the dependent there. And the key of the dependents table is going to be the social security number of the employee. So it's going to be a combination of the parent table's key and then something else which is going to create the uniqueness of the record. So you can have Judy Jones, Margaret Jones, John Jones, Michael Jones here, all linked with this social security number. So the social security number is going to appear 4 times in that kind of example. So it's not going to be a key in and of itself because it's not going to be unique. But the combination of that social security number plus the name is going to be unique. So again, if you've got 2 people there named Jones and they both have a son named Michael, it's still going to be a unique key because there'll be Michael Jones twice, but each Michael Jones is going to be linked with a different social security number for a different employee. And again, the structure will be just like as I wrote down here. The dependent's first name, social security number. So that's an example that's commonly done. So just putting it together. Designating a key will identify records in a table. Implementing foreign keys will link the tables together in a controlled manner. Normalization determines when we should have separate tables that need to be linked and when we don't. What kind of links do we want to implement? Well, in order to decide that, we think about cardinality. What's the numerical relationship between the tables that we're going to be linking together? Can you have several people working for a department? How many departments can you have those people working for? Business rules that get implemented at this point. Parent-child tables, which is, again, as I described, that's a special case. If you've got something that would violate first normal form, so you have to split it out, but it's still wholly dependent on that main table, that's something that you have to think about. Define a cascading delete. It also is going to determine what the key fields of that child table are going to be. So it's a special case that you need to think about. Planning tables. Add foreign keys to link tables. Beware of the direction of the link. Okay, one-to-many table must be on the many side, or the foreign key is going to be on the table that's on the many side of that one-to-many link. A many-to-many relationship, the relationship is made into a table itself. So the key of each main table becomes the key of the relationship table, and in fact you can add other tables as well. So like in the example of professors, you've got a professor's table and the degrees they earned. And you've got the linking table in the middle. You're basically going to have 2 fields here, which is going to be a composite key. The professor's ID and the degree. But you can also have another identifying table that's not going to be part of the key. Say in this example, you maybe want date earned, or the year they got the degree. So, where would that appear in a relationship like this? You've got the professor. The professor's table is not itself going to store any of the information about the degrees they have. You've got the degrees table that's not going to have any information about any individual professor. But this table here has the professor, the degree they earned, and you can just add a third or even a fourth field here saying, you know, they got their BA degree in 1924 or whatever. Does anybody have the time? Why don't we stop for a minute here? Does anybody have any questions, any concerns they'd like to talk about? Yeah.
What can you do from a flat database to add other tables, you know, online into it, expand the database? How's the practices for doing that?
With much pain, in short. It can be done. The basic way to do it would be to start by making a bunch of queries to the flat file that would make other tables. So for example, if you had a table of the professors and all the degrees they earned, but the degrees you had were repeating fields. So degree 1, degree 2, degree 3. Okay, that would violate first normal form, so you want to split that out. What you could do to start off with is query the database to make a separate table that would just have, say, the professor's ID number, just ask for the professor's ID number and the degree. So you'd have a table that would have the degrees and the professor's ID numbers there. And you know, if it was multi-fielded like that, you'd probably have to do 3 queries and then combine those tables together. But that way you'd have the relationship. That would actually create the middle table for you right there. Do you see how that would happen? And then you could make another table just of degrees. You could maybe query the original table, just say, give me a listing of all the degrees that are entered in the professor's table. And that would give you the degrees table. You'd need to clean that up a little bit. But you could do it, say, don't give me any prevent duplicates, give me all the degrees. You'd look through that, you'd straighten it out, you'd probably want to add a couple of things, make sure you'd have to go through all the spellings to get rid of all the duplicates that would be there, because the spellings may be slightly different but for essentially the same degree. So you'd have to do some cleanup there. And then you could make the links between, at that point you'd have 3 tables. And then you could designate the links between these. Again, you'd have to do some cleanup, because any problems that you would have in the degrees as far as, were they spelled the same way each time or not, would also be there, and you'd have to clean that up in both of these tables. But that's the kind of way you would do it. And it would work that way. Anything else? This is something that I went through just very quickly, so we don't have to spend a lot of time on this. Entity relationship diagrams, it's a common technique for planning a database to begin with. One thing that you should be clear on is that it doesn't actually tell you what tables you're going to need to create. What it does is it maps out the domain of what you're going to want to make tables about. So used to plan a system as a whole. What you want to do is determine the things about which you need to keep information, and then the relationships between those things. Things can be either concrete or abstract. And then you figure out their cardinality and the dependence they have on each other. And then the normalization, you're going to have to apply normalization to them. Let's just bring all of these in here. And again, this part of the presentation, I'm just going to quickly show you some of the little things that you can use to draw and make an entity relationship chart. Use them or not. One way that's commonly used: a box for entities, relationship or oval for the attributes, a diamond for the relationship. If you've got a child entity, you make a double circle or a double line around it. And again, for a normal connection and a child connection, you either a single or a double line. This is how you would describe a table or an entity in an entity relationship diagram. So all the attributes are out there, underline the key field. And this is how you would make the chart. A full-blown entity relationship diagram is usually big and extremely messy, but this is just a quick example of what's going on with them. I mean, departments probably going to be related to something else. Employees are almost certainly related to something else as well. But this is just a little snippet of what's going to be in an entity relationship diagram. So you have an employee works for a department. And you've got the cardinality, just an infinity sign of many, just as an open one-to-many relationship. And you've got the diamond in between. Now, the thing about this is, if you make something up like this, it's very easy to kind of see a map of the kind of thing you want to describe. In different circumstances, say you might have a many-to-many relationship in here, and then when you're going to actually make the tables, this relationship itself is going to end up being a table. But in the case of this one-to-many relationship, this relationship is not going to be a table. So it's the difference between this is not an actual map of the tables you're going to make, but it's a good way of describing what you want to talk about and the kind of data you want to store. Again, another thing you want to keep in mind is if you're looking at somebody else's ER diagram, or if you're making one of your own, the employees table is going to end up with department ID as a foreign key. You know that because they're related and it's a one-to-many relationship. But you probably don't want to stick department ID in just there, just now. Just a quick ER diagram of a parent-child relationship. And again, I've talked about what's going on here. Table diagrams, once you've done your ER diagram and you have a map of the data you need to store, start planning tables. And it's a useful thing to translate your ER diagram into something more of a schematic, just so people don't see the relationships between the things and leave out things like foreign keys. So, example, you would want to translate into something looking more like this. Professor's ID, professor's degrees, and degrees. Now, if this was an ER diagram, you would just see a diamond here and a many-to-many symbol here. The way you're actually seeing this play out is the middle table that makes the relationship. It's a one-to-many relationship and then a one-to-many relationship here. And that's just a direct translation of how you're going to have to build those tables. And that's it. This went faster than I thought it would. Does anybody else have any questions or comments or problems that they may have had with different problems or with different databases they've constructed? Yeah.
What further information should we look at? Books or articles or what?
I have a problem with that because most of the information about things like normalization, I look, I've seen Oracle database guides, I've seen a lot of books on how to do access and things like that, and almost all of them have a section on normalization. None of them I've seen have anything on diagramming, which is, that's not really essential, but normalization is really key. They have maybe 2 pages on it, which is like woefully inadequate. So, if you've read these books, you've probably seen this kind of thing before. There are some textbooks that are out there that are extremely technical and are probably a lot more than what you would want. So I would hesitate to recommend them to anybody. There's an author, El-Masri, E-L-M-A-S-R-I, who has authored a couple of really good books on database architecture. But again, they tend to be extremely technical and probably more than what you want. The best explanation that I've seen in a book that's readable is actually O'Reilly's book on MySQL and MSQL. It's a single book that actually has like 5 or 6 pages on normalization rather than 2 in a paragraph. So again, they should probably have more to really do a good explanation, but it's the best one I've seen. Yes, sir.
I was just going to suggest actually Elmaster is one of the books, but otherwise contact the computer science professor at your university and ask them for database theory books that a layman can read. That's probably the best thing to get is textbooks.
There actually is
Yeah.
a database designed for real mortals.
Oh, yeah?
Yes.
Yes, I was trying to get the name, but that's very good, yes.
What's the name of it?
Yes.
It's not the sub.
No.
What was the name
I was
again?
trying to get
You
it.
need the tables to fit. In your example, there are the employees. You've got social security number, name, and address. And then I would put zip code. And then have a zip code table with city, state, and the zip code link there. But if we needed the state to say California full, then I had another table that was a state table with the CA in California. And that link would be to the zip code. But the challenge that I'm seeing is that if you've got someone who did not design the database and wants to pull a report of employees with the full state printed out, they don't know to do that link all the way over the state. How do you do that?
Yeah. Is that actually a 2-part question? I mean,
I don't know.
this is probably oversimplifying what you've said, but like for the first part, this was just kind of an abbreviation. So zip code I would probably put in there. I would certainly put in there. And I'd probably leave it because zip codes, if you knew a zip code, you could probably resolve state, but that's probably a lot deeper than you would want to have the database work out.
So you would not.
I would probably just have, in something like this, I would probably have address, city, state, and zip.
So you
I'd have it just like that. Well, I would have these two split out and then link to this, and I would probably just have the CA in here just for purposes of making it short. But then have the separate table, state and state, state long and state short, as a separate table, and just have them linked in there. So as far as usability is concerned, that's always going to be a little bit of a difficulty with a well-formed database system, because you're always going to end up with lots of tables. Again, at the very basic level, you've got somebody who wants to delete a record from the department's table and delete the marketing department, for example. And they're going to be irritated because it won't let you because there's all these employees that are linked to the department. That's something you just really have to deal with. It's a good argument for making lots of canned queries for users to use. And that's actually how you would take care of that kind of thing. Yes?
I was just going to make a comment that has something to do also with the relative sizes. 50 states is easy to do. The names and birth dates and titles of a bunch of people are very hard to establish. You want to do it once. But I don't know how many zip codes are. There's probably, 75,000, say. So unless you have 50 million people in your record, in your database, 75,000 zip codes and cities and addresses unless you can download it from somewhere very easily, it tends to be a lot of work for very little.
Right, and that's the kind of thing at a certain point with all of these rules, they're important because they guarantee that your data is going to stay straight. And that's essential in a database system with data that's important enough to want to store. But at a certain point, things will get very convoluted, and at some points you may not want to do that with absolutely everything. You could probably split out zip code because more than one person is going to have the same zip code, and you could do that. Practically speaking, you may want to do a partial violation of second normal form just for the purposes of simplicity. There's a practical limit to all of these things. Absolutely.
Or get a hold of a download, a database of all zip codes that you can
Why would you do
Right.
that? Why would you need the whole list of zip codes? You have a single table of 26 states.
Right, I mean, you could have a table where you would just enter zip codes, and you'd just be entering zip codes of people that you actually have. And they would never, the zip codes may never be deleted, but you would have them all there, and then you could just, link them. That would actually be technically a very good thing, because then you would never have an incorrect zip code.
It also
Right, but it-
typing of cities.
Typing of cities also, but at a certain point, just practically, you may or may not want to go to that length. Again, if you're going to be doing a query, give me a list of all the people who live in this city. If that's the kind of query that you're going to be wanting to do on a regular basis, then yes, split city out into a separate table so that each city is only typed once, and that you'll never have the duplication kind of errors. If all you're ever going to be doing is printing out labels, and not querying by city, then you may want to commit the misdemeanor. So, I mean, there are practical limits to this thing. Yeah.
This may be a bad question, but I use MySQL a lot, and is there a difference between going like update and insert update records whenever you're using like relational databases and there's something like MySQL that's not fully relational?
Yeah, well, as an introductory matter, update and insert are two different things.
Oh, I know.
Yeah.
I'm just saying, inserts is really good update. If you have like a relation between tables and you do an update and you update something that's basically like a foreign key, it's not, and you try to do an update, it's not one of the existing keys.
It won't let you do it.
Okay. That's not the one.
Yeah.
Like with MySQL, you can do that at any time.
Right, and
Is that relational?
right, and what's the consequence of doing that? Is you
Just throws his hands up at you.
right.
Okay.
For example, with the employees in the departments they work in, you can put, if it's not a properly relational database, or if you haven't made the link between the tables properly, you can have people working for Department 10, Department 11, Department 12, when you've only got Departments 1 through 5 actually existing. Right, is that the kind of thing you're talking about? Right. And what you end up with is essentially orphan records. And you can do that at will in MySQL, which is a bad thing. Yeah, in a properly relational database, when you tried to do that, it would stop you from doing the insert. And would say this is a violation of the update, and you're going to need to change those department numbers before the insert will go through.
Somebody's kind of debugging. I mean, if you're programming this, it's going to make sure you capture this and debug.
Yeah, and a really good full-powered SQL compliant database does have those things. Like Oracle immediately creates an error log file of everything that didn't go through properly. Access does it to a lesser extent. Like if you're importing a table, say if you've got a delimited text file and importing it, if there are errors in that, it'll report them and make a log file. A lot of things it doesn't catch, though. With that, it would just reject the update, and you'd have to figure out what went wrong on your own.
I was wondering if you wanted to expand on that just a little bit, in that for a lot of us, basically all I ever use is MySQL, and I don't use it very often. I do a little bit of it. Are there other gotchas with MySQL other than the update, not forcing you to maintain your referential integrity? Are there other things to be aware of with MySQL that happens to be the thing to reach for and use?
I'm not incredibly familiar with MySQL. I hate to admit this, but for purposes of my Linux databases, I use MySQL because I just have little 2-column files that I don't have to do a whole lot with, and it's quick and easy. And although I would love to use Oracle for everything I've got, I actually use Access because I have small things that I'm just doing in the library, like personnel databases and stuff.
I think that's about it. I mean, that's the. You can tell the rules, but like some people, we know it'll just go ahead and break them.
That's the one that I'm familiar with.
Right. You know, you've got to read the documentation of it. I'm pretty sure that'll allow a foreign key in MySQL, right? No? Yeah, then you've got a lot of problems. And the way to do it is the way people used to do it back in the old days of, you know, big flat file mainframes, is you write triggers, which is a big pain in the neck. But
the other thing, I thought you started to say something about auto numbering, the classic, you know, first, you know, auto increment, not null.
Yes.
A lot. It starts off many of my poor MySQL databases. It's a bad idea because it's not necessary. You really ought to think about the key field. Is that what you're going to say?
yeah, auto numbering in its place, it's a wonderful thing. For example, however, like with keeping track of people, if you don't want to store social security numbers, which you may not want to do, then something like auto numbering is a real good thing, because assigning a unique number to people is much better than trying to work with names, because names will always eventually repeat. However, if you're going to store social security numbers, or if you have some other way to make a unique record, it's much better because it's much more natural to the nature of the data. And so it's a lot easier to deal with. And you know, that's a practical issue, but it's much better. That's why I hate the fact that Access is always trying to assign those auto numbers whenever it can. And people do it, and it's harder to deal with as a result. And also, also another danger of the auto numbering is that if auto number is your key, then you get into the practical problem of you can enter the same data in again and again, and it'll just get a different auto number and be a unique record. And so you can very easily get yourself into a situation where you've got duplicate data that's actually going to screw up your records by having that auto number just make everything look okay, you know, as far as referential integrity is concerned. So it's much better to use the real data when you can. Yes?
I'm thinking about a table of applicants who, many of whom only attended one college, but some of whom may have attended multiple colleges. Talk about the practical advantage to dumping that into a parent-child relationship. Is there one? So you have a table of applicants that may say college 1, college 2, college 3, college 4, as opposed to setting up a separate table for that?
Well, I mean, you've got the problem of it's a violation of first normal form to have those repeating fields. And you're either going to have it in one field with a lot of data that's going to be duplicated, and you're going to make the typos and everything. It's best to split that out into another table. So what are you going to end up with? You're going to have person, and there'll be a column. Actually, you're going to have person, and then they may have more than one degree. For each degree, there may be more than one person. That's a many-to-many relationship. There's going to be a table in the middle. Do we have something? Here, like professors in degree, the table in the middle, right? If the one professor only has one degree, you know, somebody who's absolutely brilliant and is a full professor based on a bachelor's degree, there'll only be one entry here for him, and that's fine. Right? And somebody else may have 5, 6 entries here, and that's fine too, because each will be a unique combination of person and degree. But doing it that way, you avoid the problems that you get with the repeating data for everybody else that's got repeating data. We're out of time yet. If anybody's got any other questions, I'll be here for a while. And thank you very much.